Alrighty. Unit 7, Lesson 4, page 619. Dividing powers of 10. So we've multiplied powers of 10. We've done powers of 10. And now we're going to work on dividing powers of 10. So for our warm-up is, what is the value of the expression? We have 2 to the power of 5 times 3 to the power of 4 times 3 to the power of 2, all divided by 2 times 3 to the power of 6 times 2 to the power of 4. Well, that's a lot of numbers. So let's make it a little prettier. So in lesson 2, when numbers have the same base, so like 3 to the power of 4 and 3 to the power of 2, you can add your exponents. So we now have 2 to the power of 5 times 3 to the power of, and then we have 4 plus 2 is 6. All divided by, well, we have 2 to the power of 1, remember, because there's an invisible 1, and 2 to the power of 4. So I have 2 to the power of, and then 4 plus 1 is 5, times 3 to the power of 6. So we are dividing this by all of this. Well, when you have the same on top and bottom, so let's give us one number. So let's pretend we had 10 over 10. Well, that is equal to 1. 17 over 17 is equal to 1. 2 to the power of 5 times 3 to the power of 6, all over 2 to the power of 5 times 3 to the power of 6, will also give us 1. They pretty much cancel each other out and equal 1. Dividing powers of 10. So complete the table to explore the exponents when dividing powers of 10. Use the expanded column to show why the given expression is equal to the single power of 10. You may skip a single box on the table, but if you do, prepare to explain why you skipped it. So first we have 10 to the power of 4 divided by 10 to the power of 2. So when we write it in expanded form, it breaks it off so we have the same on top and on bottom, leaving us with 10 times 10 over 10 times 10, which is 1, times 10 times 10, which then gives us 1 times 10 times 10. Well, multiplying by 1 leaves you with the same number, so I have 10 to the power of 2. That is one way to do it, and we'll do that here too. Another way, which is the same thing, is to just cancel them out. So that already gives us 1. So we didn't have to rewrite them again because it is 1. Leaving us with 10 times 10 times 10, which is 10 to the power of 3. Our problem over here, our expression would be 10 to the power of 1, 2, 3, 4, 5 divided by 10 to the power of 2. And that left us with 10 to the power of 3. The next one, because we're not going to write this one out, my writing is going to be kind of big. So I have 10 to the power of 6. 10, 10, 10. Sorry. So there's 4 of them. 5, 6, all divided by 1, 2, 3. So it rewrote them out. I am going to cross them out because they are 1. 10 divided by 10 is 1. 10 divided by 10 is 1. And 10 divided by 10 is 1. Leaving us with 3 tens. 10, 10, and 10. So I now have 10 times 10 times 10, which is 10 to the power of 3. Are you noticing anything that we're doing? If so, hopefully you're noticing that the difference between 4 and 2 is 2. So 4 minus 2. And 5 minus 2 is 3. And 6 minus 3 is 3. So what we would do here would be to subtract our exponents, because really we're taking them out because they're equal to 1. So I'm going to write down here, I have 10 to the power of 43 minus 17. 43 minus 17 gives us 10 to the power of 26. Because we're not going to write out 43 tens divided by 17 more tens and cross them out like here. You're going to subtract the 2. Use the pattern you found in the table to rewrite 10 to the nth power divided by 10 to the mth power as an equivalent expression of the form of 10 to what power? So we were subtracting. We would have 10 to the n minus m power. It is predicted that by 2050 there will be 10 to the 10th power of people living on Earth. At that time, it is predicted that we will be approximately 10 to the 12th power of trees. How many trees will there be for each person? So we're going to have trees divided evenly among our people. So our trees, whoops, that needs to be a 12, divided evenly among all of our people. So we now have 10 to the power of 12 minus 10, which gives us 10 to the power of 2, which is also equal to 100 trees per person. Are you ready for more? That one we can do. It's just one problem, the same as the first table we had. So if we were to write this, we would have 10, 10, 10, 10 divided by 10, 10, 10. So we have 1, 1, 1, 1. So they are all equal to 1. So I'm actually going to rewrite this. 1 divided by, and I can keep my 1 on the bottom too because all these were equal to 1, times 10 times 10. Which then gives me 1 divided by 10 to the power of 2. And we will get into that when you have it like this, writing it as a single power, when you have a fraction and your bottom number has that power, it's a negative power, which, I don't know, is large and small numbers, combining bases, rational numbers, other bases. Isn't until lesson 5, so Monday. So you guys will see it Monday, but that's okay. So when we write it like this, it is the same as 10 to the negative 2 power. 4.3. So far, we have looked at powers of 10 with exponents greater than 0. What would happen to our pattern if we included 0 as a possible exponent? Right? 10 to the 12th power times 10 to the 0 power with a power of 10 with a single exponent using appropriate exponent rules. So this is the rule from lesson 2. Because it's not a power of a power, it is multiplying two numbers with power. So this rule says that we are going to add our powers. So I now have 10 to the power of 12 plus 0, which gives us 10 to the power of 12. What number can you multiply 10 to the power of 12 by to get the same number? This is the same as lesson. Unit 7, lesson 2. It was on page 611 on the bottom one. And we talked about what it is when you have a power of 0. The only number we can multiply this by to get the same number is 1. So the only number is 1. We also talked about how anything raised to the 0 power is equal to 1. So any number raised to the 0 power is 1. Next page. 2a. Write 10 to the 8th power divided by 10 to the 0 power with a single power of 10 using the appropriate exponent rule. So, our rule said we subtract our two values. So I have 10 to the 8 minus 0, which gives us 10 to the power of 8. What number could you divide 10 to the power of 8 by to get the same answer? Well, just like 1b, anything multiplied by 1 is itself. Well, also anything divided by 1 is itself as well. So 1. When you divide by 1, you get the same answer. Same number. If we want the exponent rule we found to work even with an exponent of 0, then what does the value of 10 to the 0 power have to be? Well, we talked about that. Has to be 1. If I try to write 10 to the 0 in expanded form, it should have 0 factors that are 10. So it must be equal to 0. Do you agree or disagree? Discuss with a partner. So when we have an exponent of 0, so Noah's explanation starts out at right because it should have no factors or 0 factors that are 10, which is true. So factors of 10 would be 1, 10, 2, and 5. Well, 2 and 5 they just don't work. It can't be 10, and it is 1. So if we wanted to define 10 to the power of 0 as 0, we can choose to do so. However, we need to make sure it works. So if we went with 10 to the power of 3 times 10 to the power of 0, and we're saying that 10 to the power of 0, 10 to the 0 power is 0, we would have 10 to the power of 3 times 0. Well, that would give us an answer of 0, not 10 to the power of 3. Write as many expressions as you can that have the same value of 10 to the power of 6. Focus on exponents, multiplying, and dividing. So let's just do a couple of them. So to get to 6, if we're doing the multiplying rule, these two exponents need to add up to 6. So we could have 5 and 1. If we have the power of a power rule, they need to multiply to get to 6. So we could have 2 and 3. And if we go with our dividing rule, they need to subtract to get to 6. So we could do 27 and 21 because 27 minus 21 is 6. So when you're adding them, both numbers have to be less than 6. When you're multiplying them, they have to be factors of 6. And when you're dividing them, they just have to subtract to get to 6. So dividing powers of 10. In an earlier lesson, we learned that when multiplying powers of 10, the exponents add together. So when we had 10 to the power of 3 and 10 to the power of 6, we added them and it got us 10 to the power of 9. We can also think of multiplication sentence as division. Okay, so when dividing powers of 10, which is our thing today, you're going to subtract your exponents. So your numerator minus your denominator. My numerator here was 9. My denominator was 3. 9 minus 3 gives us 6. You can write it out. You can break it up and do that way. You can write it in expanded form. So you'd have 9 tenths divided by 3 tenths. You would have 6 left over. If we have large numbers like 56 and 23, is 10 to the 33rd power, because 23 factors that are 10 in the numerator or in the denominator are used to make 1. So 23 of the 10s up here are also down here. So when you divide your 23 10s up here and your 23 10s down here, you get 1, leaving you with 33 10s up top. So our rule would then be you do your top exponent minus your bottom exponent. So far, this only makes sense when n and m are positive exponents, but we can extend the rule to include power of 1 and 0. Because our power of 0 is equal to 1, we would have 10 to the power of 6 divided by 1, which gives us 10 to the power of 6. Your homework is on page 623. So evaluate, which means solve them. So you can write it all out. You can use a calculator. I suggest just writing it all out. So 10 to the 0 power, our rule tells us that's 1. So now I have 10 to the power of 3 divided by 10 to the power of 3. Our rule says we subtract our powers. So 3 minus 3 is 0. Oh, not a 3. 10 to the power of 0 is 1. This one is adding. So 10 to the power of 2 plus 10 to the power of 1 plus 10 to the power of 0. We cannot combine our powers because we are not multiplying. So we need to write this out. 10 to the power of 2 is 100. 10 to the power of 1 is 10. And 10 to the power of 0 is 1. So when we add our numbers up, we get 111. Write the expression as a single power of 10. So my top, I'm going to combine these two because I'm multiplying powers of 10. So that means I can add my powers up, giving us 10 to the power of 7 over 10 to the power of 5. And then I can subtract them based on our dividing powers of 10 rule. Top minus your bottom power. So I have 10 to the power of 7 minus 5, which gives us 10 to the power of 2. Next, we have 10 to the power of 4 times 10 to the power of 12 minus 7. So I'm going to work with this part first, and I'm going to subtract my powers to figure out what is that as one power. So I'm just going to rewrite this. I have 10 to the power of 4 still, times 10 to the power of 12 minus 7. 12 minus 7 is 5. So I have 10 to the power of 4 times 10 to the power of 5. I can now add my exponents because I'm now multiplying powers of 10. And I get 10 to the power of 9. So now I have dividing powers of powers, and I have power of a power. So I'm going to do the inside first. So I have my parenthesis. It becomes 10 to the power of 5 minus 3 to the power of 4. 10 to the power of 5 minus 3 is 10 to the power of 2 times 4. Which now I can multiply my powers. And I have 2 times 4, which is 8. So I have 10 to the power of 8. Alrighty. Next one, I have 10 to the power of 4 times 10 to the power of 5 times 10 to the power of 6, all divided by 10 to the power of 3 times 10 to the power of 7. That was a lot. So I'm going to figure out how many total 10s do I have up here and how many do I have down here. Well, since these are multiplying powers of 10, I can add them. I have 4 plus 5 is 9 plus 6 is 15. So I have 10 to the power of 15, all divided by, and then I have 10 to the power of 3 plus 7, which is 10. I can now subtract my powers based on dividing powers of 10 rule. So I have 10 to the power of 15 minus 10 to the power of 5. Last one of part 2. Multiple parts. So we have power of a power, so we can multiply them, giving us 10 to the power of 10 over 10 to the power of 6. Because 2 times 5 is 10, and 3 times 2 is 6. Now, based on the dividing powers of 10, I can subtract them. So I now have 10 to the power of 10 minus 6, which gives us 10 to the power of 4. A sun is roughly 10 to the power of 2 times wider, as wide as the Earth, and star KW Sagittari is roughly 10 to the power of 5 times wider than the Earth. About how many times wider is sun as the sun is KW Sagittari? So this one is bigger than this one. When we're trying to figure out the difference in size, how many times bigger, we're going to divide them. So we have the star divided by the sun. When we divide powers of 10, we can subtract our powers, giving us, this is a 2. It is 10 to the power of 3 times bigger, or 1,000 times bigger. Number 4 is a review from Unit 5. Bananas cost $1.50 per pound, and guavas cost $3 per pound. Kyra spends $12 on fruit for a basket for a breakfast his family is hosting. Let B be pounds of bananas and G be pounds of guavas he's buying. Write an equation to relate the two. So he has $12 and he can buy bananas for $1.50 per pound. So $1.50 times how many bananas? Plus he can buy guavas, and those are $3 per pound. I didn't need to put the dot there because I can put them next to each other. Rearrange the equation so that B is the independent variable. So that means I need to get B by itself. So I have 12. I'm going to rewrite it. So to get B by itself, I need to get it on the other side. So I'm going to subtract it from both sides. Because there's not a B, I'm writing it over here by itself. And then I also need to get rid of the 12 on this side. So I'm just going to write it in this step as well. It looks like a lot. Excuse me. So these cancel out and these cancel out, leaving us with, on this side I have negative 1.5b equals 3g minus 12. Well, I need b by itself. The opposite of multiplying by negative 1.5 would be to divide. So divide negative 1.5, divide negative 1.5. And I'm going to leave this as is. And we now have B equals 3G minus 12 divided by 1.5, negative 1.5. Rearrange the equation. So G is the independent variable. So we're going to do the same thing, but we're going to make G by itself. And piggybacking off this step, instead of doing the minus 12 on both sides, I'm going to leave it there. So I'm going to have negative 1.5 plus 12 equals 3G. So all I did is I rewrote this one without the minus 12. I just took that away because I had already done that. And the opposite of multiplying by 3G would be to divide. This needs to be. So we now have G by itself is equal to negative 1.5B plus 12 divided by 3. Number 5 is also a review. This one's from Unit 3. Lynn's mom bikes at a constant speed of 12 miles per hour. Lynn walks at a speed of 1/3 of the speed of her mom. Sketch a graph of both. So I'm going to do Lynn in red. Lynn does 12 miles per hour. So 6 miles in half of an hour. And I went with 6 because 12 is not on here. One-third of 6 would be to divide it into 3s, which would be 2. So in half of an hour, Lynn walks 2 miles, and Lynn will be in green. So it would take Lynn 3 hours to walk the same amount or the same distance. And that is it for your Unit 7 Lesson 4 video.